Casey. How are you tonight?
I'm fine. How are you?
Good. Long day.
Good.
Everybody's got finals coming up, so.
Yep, mine just happened to be next week, so.
Yeah. No, I started working with a couple of other Kent, Denver students a while back, and they said their finals are next week too. So what are we covering tonight?
Yeah. Are there any sophomores that you're talking to that I might know?
I think one's going to be a senior. He's a junior now. There's two brothers. One of them's a football player. You might know him, Jared.
Oh, Jared Vorabler?
Yeah,
Is that his last name? Yeah. He actually said something to me. He was like, "Do you talk with David too?" And I was like, "Yeah. Hey, look at that."
Uh-huh. Yeah, and then his brother Quinn is a freshman.
Oh, I didn't even know he had a brother.
Yeah, boy, and I tell you what, the brother's taking geometry, and wow, is his geometry tough. In fact, he presented me with a geometry problem last week that it took me 2 days to figure out how to do it.
Wow. Well, maybe Kent's getting a little too tough.
Well, I was impressed. I rarely encounter that level of difficult problems in geometry. So.
Well, so here I have my, let's see what we got, 87 problem review packet.
Okay.
And we've actually gone through all the answers. So I'm not done with the packet yet, but I have like 5 or 6 problems here.
Mm-hmm.
And so they're all very different.
Okay.
Well, one of them is very different, and then the other 4 are pretty similar. So
Right.
we'll see how we do.
Tackle them.
All right. So this one, it's somewhat of a word problem.
Okay.
It is x plus 5 a factor of 2x cubed? Here, I'll slow down.
It's all right.
2x cubed plus 7x squared minus 15x. And then it says show why or why not.
Okay. Something is a factor of something else if you can divide it evenly. In other words, 3 is not a factor of 7 because I cannot divide 3 into 7. 3 is a factor of 12. Why? Because when I go to divide it, I get a whole number.
Right.
Same thing with variables. If we can divide this into that and not get any remainder, then it's a factor. So let's just do long division on it. Now the trick with doing long division is just starting out dividing that into that.
Okay.
What is that?
2x squared?
Okay, next step is to take that and multiply both terms by it. And then just like in regular long division, you subtract after that. Okay, so multiply this by both of these.
So 2x cubed.
Right, and that's always going to be the same if you did your division.
Right.
But the next is different.
Plus 10x squared.
Okay, now subtract.
So we're going to end up with negative 3x squared.
Minus 3x squared. Because it's 7 minus 10.
Yep.
Okay, bring down the next term. And repeat.
So we take the x, so are we gonna need a positive?
No, so all we're gonna do is we're gonna divide that into that.
Oh, okay.
Just like we started. In other words, every time
Right.
you get down to a new level, you do the same thing essentially again.
Got it. So then that's going to be minus 3x.
Okay, multiply. Hold on, let me make more room here.
There we go.
Okay.
So we're going to get minus 3x squared. Minus 15x.
Subtract.
0?
No remainder, therefore it's a factor. And if I wanted to prove it to myself, I would multiply this by this, and I would get what's inside the radical.
Oh.
Okay? It's not really radical,
Okay.
I guess, when we're doing division, but I mean, it's not square root or anything.
Yeah.
So that's how you do long division with a polynomial, and that's how you prove that it's a factor, is by dividing it and not having any remainder. If I add, say, a plus 1 to the inside, well, now I'm going to have that remainder of plus 1.
And then it won't be a
Won't be a
factor.
factor then. It's got to divide evenly with no remainder.
All right. So then in class today, our teacher said that like one of these isn't on the that we could do a different method which she covered a little bit before to a different method of division somehow.
Synthetic division.
Yeah, could we do the same thing but involving that?
Yeah. The way you do synthetic division when you're dividing by x plus something is you assume that's equal to 0, and that would mean x is equal to minus 5, so we would divide by minus 5. Okay? Along the top goes just the coefficients, 2, 7, minus 15. Let me erase all of this stuff here. Now, when you're doing synthetic division, you're going to add. Instead of in long division, we subtracted. Well, since we're really dividing by minus 5 instead of plus 5, it means we're going to add each time. Well, the first step in synthetic division is to bring down this first number all the way down. Okay? Then you multiply this by this to get minus 10. And then you add the two numbers to get minus 3. Then you multiply minus 5 by minus 3 to get plus 15. You add these two numbers, you get 0. That's your remainder. And in fact, we know what the answer is. It's 2x squared minus 3x, which is the same thing we got when we did it by long division. In other words, because we're dividing a cubic by a linear, we know the first number is going to be x squared.
Right.
Now, there's one provision here that I didn't mention. And that is, if you're missing one of the powers of x, in the problem you gave me, we weren't missing anything. We had an x cubed, an x squared, and an x. Let me get rid of this plus 1 there. Well, let's say that it was just 2x cubed minus 15x, and there was no x squared term. We have to put a dummy one in there, 0x squared.
Oh, so to make it
in order to be able to do the long division, yes. And the same thing when you do synthetic long division. If there was no x squared, I would have a 0 right there. Then I would proceed accordingly. But you don't have to worry about it in this problem because we had an x cubed, an x squared, and an x. So I didn't have to use any dummy variables.
Okay.
But that's
Makes
the
sense.
difference. And synthetic is easier. In other words, you get everything you got when you do long division by doing it synthetically. It's just whether you know how to do it. Once you...
Yeah, it was a lot simpler.
Yeah, it is. And it's addition instead of subtraction, which is also simpler. And there's actually a theorem called the zero remainder theorem that says that something is a factor of something else only if, when you do the division, the remainder is zero. That's what makes it a factor. And so synthetically, you always need that last thing to be a zero. If it's not a zero, then this is not a factor.
Okay. That makes sense.
Okay.
All right. Let's see what we got here. These two, they involve lines. So,
Okay.
or here, this one's a circle. So it says, write the equation of the following circle in standard form.
Okay.
Identify the center and the radius.
Okay.
So here is the equation.
Okay.
X squared plus y squared minus 16x plus 4y equals negative 43.
Okay. What's the general format for the equation of a circle?
Is it, x squared...
Actually, x minus h squared plus y minus k squared equals the radius squared.
Got it. I should probably learn
Yeah,
that.
definitely you want to memorize that. And what we want to do is we want to take this equation we were given and see if we can make it look like this. Okay? And the way we're going to do that is by completing the square. So let's gather our...
Oh, you're completing the square.
Complete the square.
It's all coming back.
Yeah, you're going to do that with a lot of these conic sections, with circles, ellipses, hyperbolas, and parabolas. There's a lot of completing the square to do. So first of all, we're going to bunch our x terms together and separately our y terms together. And leave room to complete the square. So at this point, I haven't changed anything.
Nope.
So now let's complete the square on this left part, the x part.
So 16 divided by 2 is 8 squared is 64.
And then you're always adding. Since I added 64 to the left, got to add 64 to the right. Now complete the square on the y term.
You're going to add 4.
Now re-express this as an x minus h squared.
We're going to have x minus 8 squared.
Correct.
Plus the quantity of y plus 2 squared.
Okay.
Equals, let me whip out the old calculator. 25. All right.
Okay. So now we got it looking almost exactly like the general format, where h and k are the center, and this is r squared, so the radius must be 5r.
Oh.
Where is the center? If I were to graph this thing, where would the center coordinates be?
The center will be located at 8, -2.
Good. That's all you need. In other words, Once you know where the center of the circle is and what the radius is, you can graph it.
Yeah.
But that's what you want to do with all of these, is complete the square.
Okay.
And whether it's a circle, is circles the only thing you have to know, or have you done ellipses also?
We have done ellipses and also parabolas with like
Uh-huh, uh-huh,
directrixes as well.
uh-huh. And
So
also hyperbolas or not?
we have not done any
Okay,
hyperbolas.
those are tougher. Not really that tough. They're not that different than ellipses. They're just a little harder to understand. But the key
Yeah.
thing is memorizing the general formula for each. What's the general
Right.
formula for an ellipse?
Um, an ellipse is x squared plus y squared equals 1. Is that?
Close. And if you don't have an h and a k, that merely means that's the general formula for an ellipse that's at the origin, whose center is at the origin. But if
Okay.
it's not at the origin, you have this kind of thing on all of them. In other words, it's x minus h squared plus y minus k squared. It's equal to 1, and there's also an a squared under that and a b squared under that.
Okay.
And this is for, in other words, when you're dealing with circles, there's only one orientation for a circle. But when you're dealing with ellipses, you can have horizontal ellipses like that, or you can have vertical ellipses like that.
Okay.
If you have a horizontal ellipse, the biggest denominator has to be under the x, because a is the measurement from the center of the ellipse that way. So if you
All
have
right.
a vertical ellipse, this is a. And if a is along the vertical axis, it has to be under the y. So you actually have two general formulas for an ellipse. One is this over a squared, and the other is reverse the a and the b. In
Okay.
other words, a vertical ellipse, your a squared is going to be under this term over here, and the b squared would be under this. And with an ellipse, a is always bigger than b. In other words, if you look at these ellipses, that's the b measurement, that's the a measurement. It's always going to be bigger, even when it's a vertical ellipse. Okay?
All right.
So, if you get a precise equation, such as 16 and 9, that tells you that it's a horizontal ellipse.
Mm-hmm.
Because this A was 4 and this B was 3. So A is bigger than B, A is under the X, that's a horizontal ellipse. If I reverse these and they gave you something like this, then I've got a vertical ellipse where this measurement is 4, this measurement is 3. So do they have an ellipse that they give you the equation in a general format like that?
They did, and I actually did that one, and I got it right.
Okay,
So
cool. That's harder to do than circles.
yeah, for some reason that's easier to me. I have no idea
Yeah.
why.
Well, you
It
do the
just
same
clicks.
general process. You still are going to complete the square, but
Mm-hmm.
then you end up with a number on the right, and you need to divide everything by that number in order to turn it into 1. And
Right. So sometimes you might get some interesting numbers on the left side.
yeah, normally these are all going to be whole numbers by the time you're done.
Yeah.
If they're not, there's probably something wrong. In other words, you're not going to ever end up with 2.5 down
So that's kind of something that if I end up with 2.5 down there, I know that I need to go back and check my work.
Probably.
Right.
Yeah. And remember, it's a squared. In other words, the way you might end up with something like that is, say you had something like this.
Uh-huh.
In other words, that's the equation they gave you.
Right.
Well, my first problem is to make this look like 1, so I got to divide everything by 144. And when I divide everything by 144, it turns this 9 over 144 into 1 over 16. So it turns it into 16. And now you know that the square root of 16 is 4. That's one of the... This one gets turned... I didn't mean to put 16 there. I meant to put 12. Yes, I did mean to put 16. That means that when I divide 16 by 144, I end up with 9 there.
So that becomes 3.
Right. Well, it becomes 3 squared. But you're correct. A is 4, B is 3.
So if she said there's going to be a graphing one on there, so
Okay.
so let's say, just looking at this right now, how the 16 is under the x, does that mean that, so that's going to go to 4, so does that mean that it's going to go out 4 each direction horizontally from the...
Yeah, let's graph this.
origin?
Let's graph this. I put in numbers. So where's the center of my ellipse?
2, 1.
Right here.
Right around there. Yep.
Is it horizontal or vertical?
Horizontal.
Okay. And this distance between the edge of the vertex, in other words, let's go ahead and put 2, 1 there.
All right.
And A is the distance from here, the center, to the major vertex. So this would be 4 units to the right. So the major vertex is going to be at 6, 1 there, and at minus 2, 1 over here. The minor vertex is up 3. So the minor vertex is at 2, 4, and the bottom one is down 3 from this, so it's got to be 2, minus 2. So once I have all 4 vertexes and a center,
there you have it.
Now there are a couple of other things called the foci. I think you have to handle that, right?
Yeah, we have to find the foci.
Okay. Well, the foci are inside the ellipse between the center and the major vertex. And this distance is what is called C. And there's a formula for an ellipse that relates C to A and B. It's C squared equals A squared minus B squared. It's not the Pythagorean theorem, but it's close.
Pretty close.
Yeah, just change the sign. For a hyperbola, it is the Pythagorean theorem. But you're not doing hyperbolas, so let's stick to ellipses. So what would C be in our example here, where we have an A of 4 and a B of 3? In other words, C is the square root of these.
So C is going to be plus or minus 7.
Good. Plus or minus square root of 7.
Square root of 7.
Because in order to solve for C, you have to take the square root of both sides, which gives you plus or minus the square root of A squared minus B squared, which gives you plus or minus the square root of 16 minus 9. So this distance, where is the foci? The foci is the center minus square root of 7, and this foci is the center plus square root of 7. In other words, here, let me draw these in here. That coordinate is going to be 2 minus square root of 7, comma 1. This foci is going to be 2 plus square root of 7, comma 1.
Got it.
That's everything we need to know about that ellipse. We have everything. We basically, there's 7 key points on an ellipse. There's the 2 major vertices, there's the 2 minor vertices, there's the center, and there's the 2 foci. So those 7 points you want to be able to locate given the equation of an ellipse.
Got it.
And given the equation, if they give you an ellipse in this format, then you have to complete the square to get it into the general format. Once you get it into the general format, you now know what A is, you know what B is, you can calculate what C is.
All right. Well, sounds good. So, do we have time to do one more?
Sure.
All right. How about write the equation of a parabola in standard form with vertex 0, 2 and directrix y equals -4.
Okay, let's draw it. There's 0, 2, that's the vertex. When they say y equals -4, I'm going to draw that line. That's the directrix. Okay? That tells me which way the parabola goes. Does it open up or open down?
Up.
Because the directrix is always outside of the parabola. So it can't open down. All right. The general format for a parabola that's vertical, either opening up or opening down. What's your general format? And
is it y?
Enough, it's different than the general format of just the parabola in vertex format.
Yeah.
They change it. Once you start dealing with parabolas as conic sections, and you have to deal with the directrix, and there's also a focus right there, then they give you a different general format. Let's talk about the focus again. Where's the focus going to be?
It's going to be at 4 or
it's
0, 4?
It's the same distance away from the vertex as the directrix is.
Oh.
So how far away is the directrix?
The directrix is 6 away.
Okay, so we got to go up to 0, 8.
Yeah.
Now, the general format of a parabola before you got to conic sections was this. Right? Remember that one? Well, they change it. They put the K on the other side. And they put a 4P in front of there instead of an A over there. So you want to get it into this format, P being the distance from the vertex to the focus.
Okay.
So we know what that is in this case. 6.
Yep.
H and K are the vertex. So what would this equation be? It would be 4 times 6 times y minus 2 equals, well, there is h is 0, so equals x squared. And you can leave it like this. There's nothing wrong with giving that as an answer, unless they specifically say solve it for y or something, and then you'd have to algebraically solve this for y.
So, my teacher, she has the answer here as y minus 2 equals 1 over 24x squared.
Well, notice that is all we got to do is divide by 24, and we'll get that.
That's true. So it's all the same thing, just different ways of expressing.
Yeah, exactly. Another thing that we could call it is y equals x squared over 24 plus 2.
Yeah.
So I don't know what kind of... It's strange to me that this is her final format. I would think she would either use this one or go ahead and solve it for y. But they're all the same, essentially. In other words, if they don't say solve it in terms of y, then you can... This is a satisfactory answer.
Yep. And that one's a lot easier than
Well, it is.
I mean, it just looks simpler.
Well, it fits the format. In other words, notice the format. The 4p is always with the variable that is not being squared. In other words, let's go back a moment. There's two formats. Just like ellipses have a format for vertical ones and a different format for horizontal ones, same with parabolas. If I have a parabola that's like that, horizontal, then this is not y equal x squared, this is x equal y squared.
Y squared.
So I want to make sure my 4p is in front of the x. So it would be 4p times x minus h squared, not squared, equals quantity y minus k squared. Okay. So whenever you have x and y squared, and you know it's a parabola, you know it's a horizontal parabola. It can either open to the right or it can open to the left, like that. But the classical one that you've learned for 3 years is y equal x squared. So that's one way to keep them straight, is when you are looking at this parabola, you know that's close to y equal x squared. It's not exact because it's not at the origin, but if I make that at the origin, I've got a y equal x squared parabola. Well, to have horizontal parabolas, just make sure that it's x equal y squared.
All right.
Yeah, this 4p is a little confusing. In other words, not every school system actually has this as the general format. Some use the general format, the standard A. Like that.
Really?
And then they tell you that A equals 1 over 4p. So you can still solve for the focus, but it is now, the focus is equal to 1 over 4a. In other words, if I solve this for p, I get 1 over 4a. So if you are given an equation that's in this format, you can still deal with it. It's just you have to recognize that it's in your old format and not the format that we like, which has the 4p there instead of the a. And then you have your focus built in. In other words, once you figure out what p is, you know what your focus is. On this one,
that's interesting that it's not like a consistent...
it is interesting. And in fact, for a long time, I was tutoring in Colorado Springs and in Denver. And in Colorado Springs, they were using A, and in Denver, they were using 4P. And it confused me. I mean, I had a hard time keeping it straight. It took me forever to memorize this general format because I had spent so long using the other one.
Yeah. Well, thank you very much for your
You're
time.
welcome.
And this, I think I take this test either next Wednesday or next Thursday.
Okay.
So there will, we will definitely have at least one more,
Okay.
one more session, possibly
I
two.
can show you my schedule here, and Sunday is the only day that might be tough.
All right, Sunday doesn't work for me either, so
There's my
that's
next Monday, so there's some spots in the evening there. Tuesday I got
all right.
spots, Wednesday I got spots. I can't guarantee you those are going to be left open. You might want to figure out which time you want and make it as soon as you can just to be sure that you get a spot.
Yeah, I think I'm gonna go ahead and I think I'm gonna ask my parents what they think will work, and I might go ahead and book two more spots
Okay.
later this evening.
Okay. Sounds good.
All right.
Okay, Casey. Take it easy, and I'll talk to you next time.
All right. Thank you. See
You're
ya.
welcome. Bye-bye.
Bye.